The Commodore Vic-20 was a big hit with consumers, and they could have just continued making that computer and reaped the profits for years. But instead, they did what any good technology company should have done. They kept innovating. The Vic chip, which was at the heart of the Vic-20's graphics and sound production, was to be upgraded. This would be accomplished by splitting the chip into separate sound and video chips, which would be known as the Vic-2 and the SID, or Sound Interface Device. The new video chip would offer higher resolution, bitmap graphics modes, 8 hardware sprites, a full 16 colors, raster interrupts, smooth scrolling, and DRAM refresh. While the refresh feature has nothing to do with video specifically, it does allow any computer using this chip to move to the cheaper dynamic RAM instead of the expensive static RAM used in the Vic-20. As for upgrades to the sound, the new chip would have 3 voices. That may seem like a downgrade from the Vic-20's 4 voices, but these voices are much more versatile, as all 3 voices are independently programmable with 4 waveforms to choose from, and a programmable ADSR envelope, 8 octave range compared to the 3 octaves of the Vic voices, filters, and then a few other oddities like a random number generator and 2 analog to digital converters that can be used for paddles or whatever accessories they might come up with. Of course, these upgrades were not intended for the Vic-20 itself, as these changes would make existing software incompatible with the computer. However, Commodore clearly saw that games were in fact one of the biggest selling points of the Vic-20, so they decided to use these chips to create a new gaming system called the Commodore Max. The Max was quite a bit smaller than the Vic-20, and it used a membrane keyboard to reduce cost. And while it may have had vastly superior graphics and sound to the Vic-20, it had significantly less RAM, containing a measly 2 kilobytes. In fact, it doesn't even have BASIC and ROM. This is essentially a game machine, designed to run cartridge-based games. It does have 2 joystick ports, one on each side of the machine, and on the rear you get a power switch, power input, audio input, the cartridge port, a channel selector, an RF output for televisions, and a cassette port. Interestingly enough, it's missing a disk drive port and a composite video port. It seems to share a lot of common goals with the Atari 400, which had come out a few years earlier. The history of the Max is a bit fuzzy, as it was cancelled almost as soon as it was released on the market, and most surviving machines were sold in Japan. Most of the games were Japanese versions like this one, and the Max is considered highly collectible as they are very rare today, especially in working condition. And while the Max had superior graphics and sound to the Vic-20, it sold for around $200, which at that time was the going price of the Vic-20 as well. And the Vic-20 had a much larger software library, a real keyboard, integrated BASIC, and the ability to connect to disk drives and all sorts of things. So it became obvious what needed to happen. The Max was upgraded with essentially the same case and keyboard as the Vic-20, along with integrated BASIC and a full 64K of memory, and they called it the Commodore 64. Opening the box, we see, "Welcome to the world of friendly computing," just like the Vic-20 had on its box. We get a similar manual, which I'll get into later. Then of course there's the computer itself. There is some debate as to what color you would call this computer. Some call it gray or charcoal, others call it brown, and this may actually be due to the fact that the computer will actually turn brown when exposed to UV light or heat, much like white or beige computers will turn yellow. And so when somebody says they have a brown C64, it is quite possible they do. Inside this little cubby you get a power brick, an RF switch box, and a few other cables. The C64 looks remarkably similar to the Vic-20. In fact, it uses the exact same keyboard mechanism, and they are interchangeable between the 2 computers. The C64 actually does sit ever slightly lower, so the cases aren't identical. Looking at the side, you'll see they use the same power port, although earlier model Vic-20s did have a different port. The power switch is the same, but you may notice the Vic-20 has a single joystick port, but the Commodore 64 has 2. Looking at the rear, you will also notice many similarities. Both machines have the same user port, and they are compatible with the same peripherals. Keep in mind, the Commodore user port was introduced all the way back on the PET. Both have the same cassette drive port, and again, this port dates all the way back to the PET and is compatible across all 3 machines. Both machines have the same disk drive and printer port, and the monitor port is mostly compatible. However, if you recall, the Vic-20 had to use an external RF modulator. However, by making the cartridge port smaller, they were able to make room for an internal RF modulator on the Commodore 64. Other similarities between the machines is that they share an almost identical kernel and BASIC 2.0. Speaking of kernel, every time I post a picture with the word kernel spelled like this, I'm flooded with comments and emails telling me that I spelled it wrong. However, just to set the record straight, every piece of Commodore documentation spells it Kernel, Kernal, and this is the official name of their operating system. The Commodore 64 offered a great upgrade path for existing Vic-20 users. Even though the software library was not compatible, most all of the peripherals were. So if you had invested in a great setup like this, you could simply replace the computer itself and still keep all of your existing joysticks, disk drives, cassette drive, and printer. In fact, if you wanted to use some Vic-20 software again, it only took a few seconds to connect the Vic-20 back to this setup. So now that I've covered all of the ways that the Commodore 64 is like the Vic-20, let's talk about the ways that it is different. Powering up the old Vic-20, you get a friendly screen with nice contrasting colors, huge letters, and a message telling you that you are running Commodore Basic version 2, which is essentially rebranded Microsoft Basic, and you have a whopping 3.5 kilobytes free. Granted, with a memory expansion, you might see a number as high as 28 kilobytes. However, with starting up the Commodore 64, everything is very blue. The text is much smaller, and you're informed the computer is still using Basic version 2, and that it is a 64K RAM system, which was really a lot of RAM in 1982 for a home computer. And then a mysterious message that there is only 38K free. I'll explain this discrepancy later. However, needless to say, 38K was a lot of RAM for Basic, and considerably more than the Vic-20 could have, even with the highest RAM expander available. One thing I always disliked about the startup colors of the C64 is that there isn't as much contrast as I'd like, so I had a ritual that I started almost on day one, where I would press Ctrl-2 immediately after startup, which changes the text color to white, before I would do much of anything on the computer. I understand this was common with quite a few people, as the white text was much easier to read, especially on a CRT. And the Commodore 64 behaves exactly like the Vic-20, with the same 8 colors available on the keys that can be used with the Control key. However, on the 64, you could also use the Commodore key in conjunction with these keys and get access to an entirely different set of colors, thus giving access to the full 16 colors. So while the Vic-20 could essentially support two types of displays, a television connected with the RF modulator or a composite monitor, the Commodore 64 actually supports 4 different types of displays. So as mentioned earlier, you have the RF output for television, along with the channel selector switch. Much like the Vic-20, this was probably the most commonly used display in the early days of the Commodore 64, requiring one of these little antenna switcher boxes and then requiring you to tune your television to channel 3 or 4. The picture quality with this method ranged anywhere from terrible to tolerable. Sometimes you could get a better picture on one channel or the other. But you could also connect a dedicated monitor to this port here, just like on the Vic-20. And taking a closer look at the monitor port, the early 64 models only had 5 pins, just like the Vic-20. 1 pin for ground, 1 for audio, and 1 for composite video. However, this configuration is very rare, and only the earliest C64s had this setup. Most C64s you'll find will have these extra pins on the port as well, and with these you get an extra pin for monochrome video output along with a separate chrominance pin. Now, here's how that works. If you connect up to a monitor or television that has a composite input, then you'll get a much cleaner signal. Of course, this looks slightly better in person than it does on camera due to the way the refresh works, as well as the polarized nature of the sensor in my camera. So this cable here is designed to be used with a monochrome monitor, and it feeds off that special monochrome pin. And if I try connecting this to my television, it gives a really weird looking picture. The TV still thinks it's a color signal for some reason, but the colors just go nuts with the text looking rainbow. But the computer isn't actually sending any color information. However, if you get an old monochrome monitor like this one, it's not designed to even look for a color signal, and so the picture is nice and sharp. And this configuration would not be great for gaming, although many people used black and white televisions or monochrome monitors like this back in the day because they were cheap. And the last type of monitor I want to show is what is called an LCA. Notice this cable has 3 connections. One of them is audio, and the other is monochrome, or what we would call luminance signal, and the other is chrominance, which carries the color information. And if you had a Commodore 1702 monitor, which was the monitor to have with your Commodore 64, you'll notice on the rear it has 3 jacks, one for audio, one labeled Luma, and the other labeled Chroma. Fortunately, they are color-coded, so these just plug in like so. And if you think the setup sounds familiar, then you're right. In 1987, the world was introduced to something called S-Video for high-end Super VHS players, and if you look at the pin diagram of an S-Video cable, you'll see that, in fact, it is the same thing, just in a different style of connector.
In fact, it's possible to build adapter cables, and what I have here is an adapter cable I built, which has the Commodore LCA connection on one side and S-Video on the other, and this will allow me to connect this 1702 monitor up to an S-Video source, such as a DVD player, for example. And you can also build the opposite of this, which will allow you to connect the Commodore 64 up to an S-Video capable television. So Commodore may have been the first company to introduce the public to the concept of S-Video, even though they didn't call it that.
So how does it look? It actually looks great, if only my camera would cooperate better. To give you a better comparison, here's a screenshot from the RF modulator. Here's a screenshot on the same television using composite, and you should be able to see the signal is cleaner, but not really any clearer. And then here's the monochrome output, and while it's not colorful, it is very clear. And last, here's the LCA output. Please ignore the weird color banding in the background. This is not visible in person. It's a moire effect due to the polarization of my camera combined with the type of shadow mask in this monitor. So you'll just have to take my word that you can't see that in person. But look at the sharpness of the pixels in the text as compared to the other modes. One of the main selling points of the Commodore 64 was, of course, its 64K of RAM. But how did it accomplish this when the Vic-20 could not? For one thing, cost was greatly reduced by going with dynamic RAM instead of static RAM. And the refresh circuitry was provided by the new Vic-2 chip. But that doesn't explain everything. Let's have a look at the 6502 processor for a moment. There's 40 pins on this package. Now, I'm not going to go into detail on each one, but I will mention these pins here. This is the data bus. This is where numbers are sent and received between different chips on the board. You'll notice there are 8 of them, hence why this is considered an 8-bit computer. With 8 bits of data, you can use numbers anywhere from 0 to 255. That's the largest number you can create with only 8 bits of data. Now, these bits here, labeled A0 to A15, are the address bus. This is where the processor says to the rest of the computer which piece of memory it wants to read or write to. Notice that there are 16 pins. If you do the math, the largest number you can create is 65535. Or in terms of memory, that's 64K, since kilobytes are actually 1024 bytes each. And this is the reason the CPU can access only 64K of memory total. So you might think the memory map would look something simple like this. But keep in mind that even ROM is still a form of memory. So the Commodore 64 also has 8K of kernel ROM, 8K for BASIC, 4K for the character set, and another 4K for I/O space. So that presents a problem because now there's 88K of memory to access.
There are a variety of solutions to this problem, many of which can be accomplished with external circuitry. However, since Commodore owned their own chip fab, they decided a cheaper solution was just to make some minor modifications to the 6502 processor.
So if you notice, these 3 pins labeled NC mean they are no connect. They don't actually do anything. And these 3 pins here are ones that Commodore felt weren't necessary either. So they took those off, freeing up 6 pins total. So introducing the 6510 CPU, a custom CPU just for the Commodore 64. The pins are slightly rearranged, and you might notice there are these 6 new pins here. These pins are mapped to memory address 0 and are used to control banking. So there are all these other little sections of RAM that can be swapped for ROM or other things as needed. The default configuration on boot up looks like this. And this area here is the largest contiguous area of RAM, and that's where BASIC winds up having access to 40K of memory. And that explains why, when you go to the boot screen, that there's only 38K free.
And while you'll often hear me say that the Commodore 64 has a 6502 processor, technically it doesn't, but the chip that it does have is completely compatible with the 6502 processor, so from a programming perspective, it's exactly the same.
Let's talk about the graphics capabilities. There were essentially 4 modes of operation. You had text mode, where you could use the standard character set or redefine the character set. And this works more or less exactly like it did on the Vic-20. But with the 64, we also get a bitmap graphics mode. And of course, both modes have a high-res and a multicolor option, giving us the 4 different modes. So looking at the screen here, I'll mention that you cannot actually define a color of a specific pixel on the Commodore 64. The screen acts very much like a monochrome screen, but there are these character cells, and within each cell you can define foreground and background colors. This may seem obvious when you're in text mode, however, graphics mode works exactly the same way. This game here, for example, operates in high-res bitmap graphics mode. If I overlay this little grid showing where the character cells are, you'll never be able to find any one cell that has more than 2 colors in that cell, and the programmers had to work around this limitation the best they could. And here are some other examples of high-res artwork. However, if you cared more about color than you did detail, you had the option of multicolor mode, such as this game. In this mode, the pixels are twice as big, but you also get twice as much color. You can have 4 colors per cell, and this allowed for some really colorful artwork to be created. Here are some other great works of art that operate in multicolor mode.
Of course, that's not the limit of the C64's graphics, because it also has hardware-driven sprites.
And there's no better way to show you how these work than the Commodore 64 User's Manual. The User's Manual isn't quite as good as the one that came with the Vic-20, but it's still pretty good, and it has an entire chapter on how to program sprites, and they give an example program for creating a single monochrome smiley face sprite. So I've typed in this program so we can see what it does. All it really does is define the sprite and then move it across the screen like this, and then the program ends. One of the things you'll notice when I list the program is that it stays right there. In fact, I can even cursor over here and try to type over it. It has no effect, even if I use the backspace. The sprite is totally independent of the rest of the screen. So let me show you some other things you can do with the sprite, such as change its color. It can be any of the 16 colors, and there are even multicolor sprites that can have up to 4 colors. You can also overlay sprites on top of each other to add more color if needed. I will also point out that the sprite doesn't care about the color cells. Its colors are totally independent of that too, so this makes them very handy for moving objects that cross the boundary of color cells. Another thing we can do is change the size. This register will make it double height, and this register here will make it double width. And if I want to move the sprite, I can put in a new horizontal coordinate, or even a new vertical coordinate. So that's how sprites work. Sprites were an important part of Commodore 64 games, as it made coding things that move much easier. In fact, just to show you what a difference they make, check out the Vic-20 version of Qbert. It's terrible. Yet the Commodore 64 version looks as good as the arcade. And you can pretty much give most of that credit to the hardware sprites. The sound interface device, otherwise known as the SID chip in the Commodore 64, was revolutionary as far as computer sound was concerned.
I can safely say that in 1982, no other computer or video game system had a sound chip as sophisticated as the one in the Commodore 64. In fact, most other computers at the time, like the IBM PC and the Apple II, could only produce simple beeps. In fact, I don't even think Commodore realized how advanced the chip was in the early days.
Most of the early games released in 1982 simply used the SID chip for some sound effects. Probably the first program to really exploit the SID chip for music was Commodore's own Christmas demo released in 1982. By the next year, many games started to incorporate musical tracks. Games like Mule just assigned each voice to be one instrument, and then they stayed that way for the duration of the song. And to be honest, this sounded pretty cool in 1983 compared to what you'd hear on most computers. But then after another year or so, musicians started figuring out that they could dynamically reassign voices to different instruments as the music played, which creates the illusion of more than 3 voices. This becomes more apparent if you listen to these songs one voice at a time. Also, many games started to take advantage of the SID chip's ability to play digital samples.
Ghostbusters! Another visitor. Stay a while. Stay forever.
The Vic-20 had been a market leader for low-cost personal computers with seemingly nowhere to go but up. Despite the higher price, the introduction of the 64 more or less killed the Vic-20 sales, causing Commodore to quietly discontinue the computer sometime in 1985. This was not really a problem, as the Commodore 64 by itself essentially owned the largest part of the personal computer market in 1984, easily outselling the IBM PC and all of its clones, along with the Apple II, Atari, TRS-80, and everyone else. I didn't put any percentage numbers on this pie graph, as these are really just estimates. Finding hard sales data, especially on some of these other machines, is very difficult, and some of it's contradictory, but I think this chart is roughly correct. Still, I cannot understate the importance of the Commodore 64, as stores like Kmart, Target, and Toys R Us were heavily promoting and selling these computers.
Of course, the Commodore 64 was not perfect. It did have some significant disadvantages compared to some of its competitors, particularly because its BASIC was a little bit on the weak side. This was mostly because it lacked any commands for graphics or sound.
So people learning BASIC on an Apple II could write simple programs that could produce colorful graphics on the screen, and programming graphics on the Commodore 64 required addressing the video chip's registers directly, which was much more complicated and confusing to newcomers.
Another problem with its BASIC was that it lacked almost any disk drive commands. The only 3 commands that it supported directly were load, save, and verify.
Anything else, such as formatting a disk, required sending cryptic commands directly to the disk drive, and copying files from one disk to another actually required an entirely separate program. And to make matters worse, the disk drive was the slowest in the entire personal computer industry due to a bug that dated back to the Vic-20. And even though Commodore had changed the color of the 1541 disk drive to match the Commodore 64, it was still the same disk drive inside, and it was interchangeable with the Vic version of the drive.
And so the 64 shares the same slow disk drive access problem as the Vic-20. However, this wasn't a huge problem because several third-party products sprang up to solve this problem.
For example, to solve the weakness of BASIC, 2 cartridges were available, such as Commodore's own Super Expander cartridge, and then the more popular third-party cartridge called Simon's BASIC. Both did the same thing, which is to add new commands to BASIC, making it much easier to create graphics and sound. As far as the disk drive shortcomings, several third-party products address this, one of the most popular ones being the Epic's Fast Load cartridge. This cartridge not only replaced the crummy disk drive routines in the kernel with faster ones, speeding up load times by as much as 5 times, but it also included shortcuts for many commands. For example, instead of typing out the usual load command like this, you could abbreviate it with a slash. And if you wanted to find out why your disk drive was flashing with an error, you could just type in the @ symbol to get the status of the drive. It also had a menu you could access which gave options for copying files or disks and making life a whole lot easier. And this was considered a must-have cartridge for Commodore 64 users. Another problem is that schools that used to use the Commodore PET in classrooms were switching to Apple II and other products because the Commodore 64 was not well suited for classrooms. The computer was too small and easily stolen or broken, plus there was a mess of cables everywhere. And to address this, Commodore used a similar case and monitor to the PET and placed a Commodore 64 motherboard inside and rebranded it as the Educator 64. Unfortunately, by this time Commodore had little success gaining back the business of schools, and these machines are pretty rare today. The next year, in 1984, Commodore came out with the portable version called the SX64, which retailed for $999. This system was designed in the familiar luggable form factor that several other computers from the time period used, such as the Osborne, the K-Pro, and compact luggables. It included a tiny 5-inch color screen, although the default startup colors were changed to give a higher contrast on the small screen. The built-in disk drive was compatible with the standard 1541 of the era. It was 100% compatible with all software for the Commodore 64, with certain exceptions. For example, the machine lacked a cassette port, so anything requiring the use of a cassette drive would obviously not work. Of course, by 1985, the entire landscape of personal computing had changed. Just a few years earlier, computers were all about using BASIC to write your own software or games, or typing things in from magazines. And the best games you could get were arcade-style games that came on cartridges just like game consoles. But as the market had changed from a hobbyist computing scene to more of a mainstream computer product, BASIC was almost forgotten. Video games were where the market was, and due to the limitation of cartridge games only being able to hold 16K of information, they also quickly became a relic, replaced almost entirely by games on floppy disk. Disk-based games allowed the 64 to use all of its memory, which allowed far more sophisticated graphics, sound, and game styles. Of course, some markets such as the UK and Australia never really adopted disk drives, and thus most games in those markets were distributed on cassette tape. While the cassette had serious disadvantages over the floppy disk, it did at least have an advantage over cartridges since there was no size limit for programs stored on cassettes either. In 1986, Commodore finally gave the 64 a complete makeover. They called it the Commodore 64C, and it came in a bright beige color with a design to match the Commodore 128 that came out a few months earlier. It also got a new matching monitor and 1541 disk drive called the 1541C. And shortly after that, they replaced it with the 1541-2, which was a smaller drive and finally included dip switches on the back to change the device number. The computer was supposed to be 100% compatible and essentially the same machine. However, beyond the changed appearance, several other changes were made in the name of cost reduction. Some things were just minor differences, such as the keys. The original keys had the graphics characters printed on the side of the key, where the 64C had everything printed on the top of the key, so that it was cheaper to print them. Inside the computer, there were far fewer chips, as many chips had been combined to reduce cost. Even the RAM chips were reduced. While the original version had 8 chips, the new motherboard had only 2. Of course, both machines still had 64K. They also moved to a different chip manufacturing process.
The new version also used lower power chips, which in theory means they should run cooler and therefore more reliable. But one of the biggest changes that people argue about is the SID chip. The SID chip sounds a little bit different between this machine and this machine. Now, which one sounds better depends on who you ask. Also, there's some confusion over the names of these machines. So the white or beige model is, of course, officially called the 64C. But what do you call this model? The only name Commodore ever gave it was the Commodore 64. But in order to help differentiate the two computers when discussing the computers online or via email or whatever, people often refer to this machine as the bread bin or the bread box. Now, why? Well, it kind of looks like a bread bin. At this point, you might think the Commodore 64 had reached the end of its life on the market. However, it continued to sell very well. However, at this point, the competition in the personal computer market had changed and the Commodore 64 was no longer at the top of its class.
By this time, the top end of the market was being dominated by 16-bit machines like the Amiga, MS-DOS computers, and the Macintosh. With further price reductions, the Commodore 64 continued to dominate the low end of the computer market, being the most affordable computer with a huge software library. While it started out selling for $595, you can see it here in the Sears catalog selling for $149, which is a cheap computer even by today's standards. The games for the C64 continued to get better and better as software developers learned how to squeeze more out of the system. And while it's awesome that the C64 was even able to play these games, admittedly it was falling behind compared to the 16-bit competition, especially when it came to 3D games like these. Still, it had the advantage of being half the price, or in many cases a quarter of the price of the competition, which still kept the system selling like crazy. Nevertheless, the 64 continued to find new uses. One brilliant move was to bundle GEOS with the new 64C. GEOS stands for Graphic Environment Operating System. It works with the Commodore 1351 mouse and gave the Commodore 64 a general-purpose graphical user interface for the first time. GEOS was bundled with several useful applications such as GeoWrite, which is a word processor offering a what you see is what you get experience for the first time on these machines, much like the Macintosh had been offering for a couple of years already. Also included was GeoDraw, which was an art program. Many additional programs were available for GEOS, such as a spreadsheet and a variety of other software, which helped to breathe new life into the 8-bit machine as it could now do many of the same tasks that 16-bit machines were doing. GEOS would run even better with the addition of a RAM expander. While modems had been available for years, by this time they were starting to catch on a bit with the general public, allowing you to access information beyond your local computer. These modems connected to standard telephone lines, which meant that the telephone could not be used while the computer was using it, unless you had more than one telephone line in your home, which most people did not. And while the internet technically existed, it was rarely used by anyone at this point. However, many other proprietary online services started to become popular, such as Quantum Link.
These disks were often given away for free inside of other boxes of software, or sometimes in magazines, or even inside boxes of hardware like modems, for example, in an effort to get more people to subscribe to the service.
Quantum Link provided a variety of different services that could be accessed via a modem, everything from chat rooms with other users, gaming, email, downloading new software, home shopping, and reading the news. So, believe it or not, people were doing these things all the way back in the 1980s, even though it didn't become mainstream until the mid-1990s when the internet became popular. Another popular online system for Commodore users was called Habitat. With this service, you could chat with your friends online using little avatars that you could customize to your liking, and then you could roam around this virtual environment or habitat and interact with things while chatting with your friends. And there were a variety of places to go and things to do, and you might say this was one of the first online multiplayer games, although the main purpose of it was for socializing.
As the machine aged, in the year 1990, Commodore made one last-ditch effort to breathe a little bit of life back into the Commodore 64 platform, and that was by their attempt to release the Commodore 64 GS,
which stands for Gaming System. While the concept may seem similar to the Max platform, this version did at least have a full 64K of RAM, making it much more powerful. However, the software library was still very limited because software would have to load from cartridge, which most games abandoned years earlier. And any software that required a keyboard would not work.
The machine was ultimately a market failure, and thus it is also very rare to find one today.
Throughout its lifetime, there were numerous hardware add-ons and peripherals developed both by Commodore and third parties. These are just some of them. There were a variety of input devices, such as this light pen, the koala pad, a mouse, and paddles. Also things like RAM expanders and 80-column text displays, the Magic Voice speech synthesizer, and here's another speech cartridge. This is an FM music synthesizer cartridge. There were musical keyboards like this, and here's a video digitizer to grab still images from composite video sources. This is a 3.5-inch disk drive that would allow you to use what was at the time more modern disk types, and there were a slew of different modems, both from Commodore and third parties. There were other things like speech recognition devices like this VoiceMaster headset, and the sound sampler that would actually allow you to record sound clips to your computer. And then of course there was the incredible musical keyboard, which was popular probably because it was so simple and cheap, and it was just an overlay for the keyboard. Of course, all good things must come to an end, and in 1994, after 12 years on the market, the Commodore 64 finally stopped production. However, that didn't stop hobbyists from playing with the computers, and they continued to remain popular, especially with demo coders. Demo coders are basically people who find it challenging and competitive to see who can make a computer with limited capabilities do new and interesting things. And while demos have been made on almost every old computer, the Commodore 64 remains one of the most, if not the most, popular architecture to do this on. The computer saw something of a revival in 2004 with the introduction of the Commodore 64 DTV, which stands for Direct to TV. This little joystick contained an actual Commodore 64 condensed down to just a single chip, along with a RAM chip and an EEPROM to store the games. And in 2018, which is basically right now, the C64 Mini was released, which is a similar product, although it runs on an ARM processor running an emulator rather than being true to the original hardware.
Interestingly enough, it is almost possible to build a brand new Commodore 64.
There is a company currently producing the 64C case from the original molds, and they're identical to the original cases, only made with modern plastics, and you can get them in any color you want. Combined with that, there's a company that's producing a modern motherboard that will fit the case. The only catch is that some chips, like the video chip, must be sourced from original computers, as there's nobody producing those right now. So you can buy and build about 90% of a Commodore 64 from brand new parts. Hopefully someday we'll get that up to 100%. Even to this day, new games are being created and sold for this computer, with more new releases coming out every year than possibly any other vintage computer. For example, in 2017 alone, there were over a dozen really good games released for the Commodore 64, and development continues. Of course, the C64 has made its mark on popular media and been featured in many popular TV shows of the era, such as this episode of Red Dwarf. But more recently, it's been seen in shows such as *Halt and Catch Fire*, where Season 2 practically revolves around the Commodore 64. And let's not forget the movie Pixels, where if you look over to the left, you can actually see both the bread bin and the 64C right next to each other.
Okay, and so that about wraps it up for the Commodore 64, but I do have a few more things to tell you. First of all, when I set out to do this Commodore History series, I wanted to tackle these computers chronologically, starting with the PET and ending up with the Amiga. And so I'm definitely still following that line. However, I did want to mention that because the Commodore 64 was in production for so long, that it, chronologically speaking, overlaps the birth and death of many other Commodore machines. So when we move on to the next episode, which is going to cover the Commodore Plus/4, we're going to have to jump all the way back to 1983 to talk about this machine. So don't be confused when that episode comes up next. And so that's it for the moment. So stick around for the next episode, and thanks for watching.